Welcome aboard, ladies and gentlemen. It's Wednesday night. You know what that means? Another edition of Grassroots Motorsports Live, presented by CRC Industries. I'm JG Pasterjack. We got Big Blue up on the lift today. We got all kinds of cool stuff to play with. We're going to be talking to some new friends from Improved Racing, all about oil control, oil cooling for your LS motor. And we've got lots of cool stuff to show you guys, lots of cool stuff to play with. And, if I may be a homer here for a minute, all of it built right here in the beautiful state of Florida. So thank you for contributing to the local economy. Improved Racing, thank you very much for that. Here's what I want you to do before we get going, though. Do the social media thing. Give me the likes, give me the shares. I'm watching for comments over on YouTube here. I'm watching for comments on Facebook right here. I see a lot of our regular friends. Yes, somebody noticed my haircut. That is, thank you, Greg, who's one of our winners from last week. So basically, come a Monday night, I'll take a couple Ambien, cut my own hair out in the middle of the lawn. It's a lot of fun. It's one of the things we do around here to blow off some steam. So let's, before we get down to the show, let's spare a thought for my friends over here where are they? In the lower left-hand corner of the screen, our friends from CRC Industries. Check them out at crcindustries.com. Even better, check them out at a major retailer near you. We just pulled the exhaust down off of the Corvette here. I had sprayed it with CRC freeze-off a couple days ago. Came off, it was like butter. It was like, I didn't even need a wrench. Did it by hand. It was fantastic. Also, check out our friends at Autobooks Aerobooks out in Burbank, California. Autobooks-aerobooks.com on the web. Even better, go pay a visit to them there in Burbank. Check out any of their tens of thousands of books, magazines, DVDs, videos. Later in the show, we're going to be telling you guys about what's going on next week at the Rolex. Of course, our big fan fest, GRM Experience at the Rolex. Katie's flipping the board over back there. You can go to grmexperience.com. And if you have a phone, you can text Rolex, R-O-L-E-X, to 31966. Here, give me the board, Katie. So,
1996.
oh, sorry. Ignore everything I just said. You can text Rolex to 31996. We'll put that in the comments there. Nothing I say is true. 31996. You'll get updates about what's going on during the weekend. If you're out there, maybe you want to go on one of our tours. Maybe you kind of want to know what's going on at the big party tent. We'll send you updates, and it'll be a lot of fun. All right, let's get down to it. Let's bring on Michael Ihns from Improved Racing. Good to see you, my friend.
Thanks for having me.
Welcome aboard. Thanks for making that I-4 drive over to see us. So, part of this is an apology because you have been a member of the Central Florida sports car community for a long time, and we haven't really met each other yet, but we're fixing that tonight. So tell us, to get things started, tell us a little bit about how you got into this world here.
I started the company back in 2008. I was an engineer at Lockheed Martin. I had a Mazda RX-7 that I LS swapped, and there was a need for some custom products, and I started making stuff. So the first product we ever made was an oil pan baffle. We had oil starvation issues, cornering at the track. So, we just got into oiling, doing that, and started making more products, and we went from there, started doing it full time.
And so that's awesome. So what problems are you trying to solve? It's mostly LS based, and I know that LSs can have a few kind of quirky oil things going on. What are some of the problems you're working on solving with this stuff?
So we specialize in oiling, oil control, everything from controlling the oil to prevent oil starvation in the pan with baffling and crank scrapers, to oil temps as well. Cooling, thermostatic oil controls. We have a few patents on oil thermostats. It's kind of one of our big things. And we started off with the LS. That's what we specialize in. We're starting to get into some Ford stuff. We're making stuff for the Coyote and the mod motor. And we're starting to make some more universal parts too, like filter mounts. We have a thermostatic remote filter mount, which is pretty cool. Not a lot of people make that. You're just, kind of expanding out, but oiling is our thing. That's, what we specialize in.
So how do I know if I'm a track guy, if I'm an autocross guy, if I'm a road racer, how do I identify an oil problem before it's too late? I mean, it's easy to identify when your engine builder sees the hole in the block.
Right.
How do you figure out what problems you need to solve before then?
I mean, monitoring oil pressure is key, right? So we always tell everybody you have to run a good oil aftermarket oil pressure gauge, preferably with an alarm of some sort. Because when you're on the track, you're not watching that gauge. You're not going to, see your pressure dipping for like a split second on a turn. Right. So you need some kind of alarm, like a light, or I prefer a buzzer, so you can actually hear it. A light's good, or both. But that's the first step. Some people ask us, do I need baffling? Do I need this or that? And I say, well, do you have a good oil pressure gauge? Like, how do you know what's going on with your oil pressure? If you don't know that, you don't know what to do. So you might be fine, it kind of depends on what you're doing. So monitoring oil pressure and oil temps is also important, but oil pressure is that's the big thing.
So what are my baselines if I'm monitoring oil pressure? Where am I setting my alarm? Is it, like, if it drops below a certain level momentarily, is that panic, or is it for a certain amount of time?
It varies with the engine. The best thing obviously is data logging, because you may not even see a small dip in the gauge. And if your pressure drops too low for even a split second, that can cause some damage. So the data logging is the best thing. You can look at it, afterwards. But like I said, the pressures vary by engine. If you have a built motor, you want to talk to your engine builder and see what they recommend for oil pressures. But typically, if you're at high RPMs on the track, you don't want to see your pressure drop in below like 30 psi. You might see some drops, but it should be up at 60, 70 when you're at high RPMs.
Yeah, well, and the nice segue there, Brett, over on YouTube, when we're talking about oil temperatures, how hot is too hot? And by the same token, is there a too cold that we can
absolutely
achieve
yeah
that we don't want want to push the motor below a certain temperature?
Right. So we see a lot of people getting their temps up to about 300 Fahrenheit before they back off, which is way too hot. The main thing is you need your oil viscosity to be to not be too thin, right? And when it gets hot, it's just going to get too thin. And there's something that they call a hydrodynamic wedge, which is basically the film of oil that's supporting your bearings. And if the oil viscosity gets too thin, you break that support, that like film of oil, and that's where you get contact with the bearings, and that's where the bearings get hot and you get a spun bearing and all that. So you have to maintain your oil viscosity. So 300, way too hot. You can't really avoid on a real track car sometimes going up to like 270 or so, but that's kind of like where we like to see the limit. And you got to run a heavier weight oil when you're at those higher temps. But we've had customers running 300, and we set them up with an oil cooler and everything, and they're going max about 260, which is pretty good. That's pretty good for a track car. You just want to run a little thicker oil. And then on the low end, people run a big oil cooler with no thermostat, and if it's a street car, you absolutely need a thermostat, because you're going to see your oil may never even get up to temp with casual street driving, cold weather and that kind of thing. So we see people who are like, yeah, my oil temps don't go above like 120, like 110, and so if it's a street car, you run a thermostat, and that solves that issue. So we try to keep it. I like it to be 200 or so, on the low end. 270 is kind of the max I try to see at the track. But anything above 180 is good on the street.
And if you're talking about 270 being the max, is that 270 the max on the last half of the last lap, or if I'm at 270 for 20 minutes,
you're probably okay. Yeah, I mean, a lot of like endurance cars are going to see those temps for a long time. Some cars, we have a thermostat that the Corvette racing team uses, the C5R and the C6R. They were actually seeing their temps get too low on some tracks. I think it was Le Mans. In the rain at night, their cooling system is so good that their temps were getting down like 210, 200, which was too low for how optimized that engine is for the certain operating temp.
Your oil temps being too low in your factory Corvette at Le Mans is the most first world problem
insane.
I have ever heard of.
It's insane.
In my life.
So that's why we have a 212 Fahrenheit thermostat. They asked us to make that, because that's 100 Celsius, that's the minimum they wanted to see. So we made that temperature for them, and we recommend that for track cars that are running higher viscosity oil, because you don't really want your oil to get down. If it's down to 200, it might already be too thick.
Gotcha. And actually later in the show,
you lose horsepower.
Yeah. So a little later in the show, we're actually going to be bolting on one of your thermostats here.
Yep,
this is the LS thermostat. Really slick. I want to hear about how this works. But we're Michael's getting ready to do a basically a kit for the C5. So you guys have kits for C6.
C6. We have one for the Camaro
Okay.
coming out. Like it's basically done. Some parts are the brackets and stuff are production. Probably be out like sometime in February.
Okay.
Because
Camaro, we had a 2015 Camaro a few years ago. We had all kinds of oil cooling issues with the thing. Just
yeah,
because
they do have a lot of issues. Yeah,
and
we're running like the biggest cooler we make for that car.
Yeah.
Yeah, we have a kit for the 4th gen Mustang that's almost ready, and we're
cool.
going to do also for the newer Mustangs as well, for the Coyote motors.
Cool.
I'm working on that too. So, and then the
and
C5 hopefully very soon.
Coming in a couple of months. Yeah, we're going to take the car over to Kissimmee there and get it hooked up. Let's see if we missed anything. Yeah, actually, Brett mentioned factory gauges being wacky and some of the GM stuff. That's something you and I were talking about on the phone. When we had our Camaro, one of the issues with it was we were seeing oil temperatures from the factory gauge like that were crazy, 320, 330 degrees. Like, there's no way this can be that bad.
Yeah.
But those cars don't actually physically monitor the oil temperature.
Yeah, that's what we've kind of discovered. They don't have an actual oil temp gauge. It's got a coolant temp gauge, and because the oil's temps are cooled with the heat exchanger with the coolant, GM thought, hey, we'll just kind of see what it is relative to the coolant and just make the computer kind of give you an estimated temp. So it confuses a lot of people because they'll put a huge, massive oil cooler on. They're like, wow, my temps are exactly the same. And, so you just can't trust that factory gauge. You have to put an aftermarket gauge.
And I think what we ended up doing is we worked with the Chevy engineers, and they actually sent us a modified drain plug that they had built that had a temperature probe in it.
Right,
and I think they gave us like a different flash for the computer that could make more accurate track-based.
So they knew what was going on.
It was something they were aware of, but we're like,
right.
Yeah, we never really thought we'd run into this too much. But I can only imagine the pressures that are on somebody developing a car. At a corporate level that
trying to save money, like save a couple bucks on that, oil temp gauge.
So Joe's got a good question here on Facebook. Is there an ideal oil temperature for different engines? I mean, does an L is 210 to 260, is that ideal for most internal combustion engines, or is that like an LS thing? If you got a rotary, it should be different. If you've got a 4-cylinder,
yeah, I mean, it probably is a little different for rotary. I think rotaries, you try to keep it like as cool as you possibly can.
Rotaries just try to keep the oil inside
just so temperamental.
Yeah.
Again, it depends a lot on the motor. Built motors, your engine builder kind of recommends something, but it's all really about oil viscosity and having the right oil viscosity.
Depend on the oil as much as anything.
Like I said, if your oil gets too thin, you're going to spin a bearing. So, and that'll happen at high temps. But if you have a thicker oil, you'll be able to go a little higher. So these guys we have a lot of customers running 300 Fahrenheit temps. They're running like a 50 weight oil, and they haven't blown their motor. Usually they'll back off when they get to 300, right? But they'll be up in those temps. If you run like a 30 weight oil at those temps, you'll be doing damage pretty quick.
Cool. All right, so let's look at some of the stuff here because the stuff is very, very well made and very nice. So thank you for bringing this stuff to Florida. First off, I just found out about these tonight. These are amazing. This is the kind of stuff I live for, like this clever stuff where you took something apart and went, oh, I could make something to go in there. Like I have that same mind, just what I would build would look like this table. Right. That would not really be as effective.
And that's what our prototypes look like, but then we draw it in CAD and get it machined properly.
So these are actually little swinging trap doors that keep oil in place.
Inserts
that snap into this Batwing oil
for
pan.
the factory pan. Yep.
So no welding required, no threading or tapping.
Right. We try to make everything we make as bolt-on as possible and as easy to install as possible. So. It just goes right in there. Yep.
Yeah. So what's something like this going to cost the customer?
So this little kit here, so it's got 3 trap doors, and it doesn't look like much, but these are billet CNC machined little clips on here, and these trap doors are not just hinges; they're specifically made for our baffles. We use these in all our baffles.
Okay.
But yeah, this kit is $199. Our baffles are all most of them are all $199 as well. And the other ones are much more substantial because they're actually a whole baffle that bolts into the pan.
But that's if like this is made specifically for this LS6 C5 oil pan, which is a pretty good pan to start with, supposedly.
It's probably the best factory pan as far as preventing oil starvation, controlling the oil.
So could you put an objective figure on this? Like what is this gonna? How is this gonna change? Like how much more time at 1G is this gonna give me with oil in there? Or?
Yeah, the numbers we usually see is like pretty much everybody around 1G. Sustained or peaking, like you see it obviously more on longer turns. The longer you're sustaining that type of lateral force is, you'll see the oil pressure drop. But around 1G is kind of the limit of most of the factory pans. Okay. The C5 pan is definitely the best one. It might be a little higher than that. With our baffles, people are going up to peaking like 1.4 or so, and not having any
before you're seeing
totally steady oil
pressure.
Drop. We have had people see drops in oil pressure. I mean, these are like serious track cars with slicks and aero and everything. At some point you kind of just have to go dry sump.
Yeah.
But you could add an AccuSump, like an oil accumulator as well at that point. But they're pretty good for that. And then for drag racing as well, people use it for that. But we constantly see with stock motors around 10-second quarter mile, you start seeing drops in oil pressure on launch. And then with our baffle, people get down to like high 8s, low 9s, and then they start seeing drops again. And it's like the baffle can only do so much. But
that's cool. And that it's such a simple, elegant solution to a complex problem. But like I could just sit here and play with that all day. I would never actually install it. So, okay, so let's take a look at some of the actual pan stuff. So this is a crank scraper, which sounds like something you would get from one of those massage places out by the airport, but it's not. So what this actually sort of hugs the contour of the crank, and what is this actually? Is this just breaking up the foam in the pan, basically?
Mostly what it's doing is, so your crankshaft is spinning through here. Your rods are kind of going through. This contours, this one's made for H-beam rods, and there's like even a little ridge on most of the rods that'll go right in there. And the counterweights are getting scraped off here on the sides and on the ends. Like most of the oil is actually being scraped off the counterweights. But what that does is as the crankshaft spins through here, the oil gets scraped off on this side and just gets dumped into the pan. And in fact, there's so much oil on that crankshaft that you're removing that you're effectively lightening your rotating assembly. Okay. And we see between 5 and 10 horsepower at the wheels gain in horsepower by adding this.
Just from the frictional loss of carrying
just the extra weight,
additional oil.
Yeah, you're basically like lightening your crankshaft, your rotating assembly, and that takes up horsepower to spin all that oil.
And you're also probably preventing some of the pressure that would accumulate like in the top of the pan from that oil just foaming and aerating.
Yeah, there's a lot of oil. When the crank comes back up, it's just flinging oil all over the place, and you're kind of minimizing that. So you get the oil down into the pan faster and more of it down into the pan. So and this is a two-piece part, right? So this bolts to your mains, and it does require a little bit of alignment, just fine-tuning to make sure you have clearance around everything. So you bolt that up, and then that's the windage tray section of it that actually this goes like this. This bolts onto that. So once you've got it lined up, you bolt the windage tray on. That's basically it.
Okay, this
is no modifying, nothing. Yeah. We have ones for basically almost every LS pan. They're specific for the pan, the crank, and the rods that you're using. So we have ones for aftermarket 4-inch stroke, factory stroke, factory stroke with aftermarket rods. So basically all the common combinations you could possibly have. So
when the phone rings and somebody says, "I'm building a motor, I'm going road racer, I'm going time trials, or whatever. I need oil stuff."
Yeah.
What are you asking them? How are you trying to direct somebody to the right stuff based on trying to figure out what they need?
Yeah, we ask them what they're doing with a car. If it's a road race car, a drag car, how crazy they're planning to get with the car. If they're going to be doing slicks or aero, that kind of stuff, and then we just start asking questions and what their setup is and what the car is and all that, and we start making some recommendations. We try not to, so much sell them on it as much as just give them information and help them figure out what they need, and the parts kind of sell themselves. So, it's always a conversation, just figuring out what they're doing and what you're planning to do with the car. Cool.
So we got some good questions coming in from our gang over on YouTube here, and we'll move into cooling a little bit. So we talked about the Camaro stuff a little bit, and the fact that they were monitoring temperature is kind of weird. Is there if you're adding a gauge to your car, which it sounds like you recommend everybody add a good gauge,
right?
Where should they be monitoring oil temperatures? Is one place better than another, or do you just have to understand what they're going to be based on where you're monitoring?
You need your so your oil pressure it can be almost anywhere. The pressure will be slightly lower at the top of the engine because you lose there's a pressure drop through all the components of the motor. So the factory oil pressure gauge on most LS engines behind the intake manifold on the top of the engine, and that's why they put it up there, because that's kind of the pressure that you're seeing, on the bearings and everything. That's kind of the ideal place, but it's not a huge difference from putting it there, from putting it like on the oil lines or on the oil cooler adapter. We have a location on the oil cooler adapter. Now, temps, on the other hand, that's very important because that can vary dramatically. If you have your oil temp gauge before the cooler, after the cooler, obviously you're going to see a difference in temps. We've had quite a few customers are running a tiny like -3 turbo feed line to their turbos, and they put their oil temp gauge like 15 inches down that line near the turbo, and you're not getting accurate oil temps at all. The oil temp is like 100 degrees lower on the end of that line than it is on the primary like oil flow. Okay. So we run into that a lot where they're like, oh, my oil temps are super low, your thermostat's not working. We're like, well, where's your temp sensor? And that's a lot of times the issue. So
do you have, I think somebody asked earlier about a preferred gauges? Like, you guys sell monitoring equipment
we
as
don't.
Well? Anything you like out there?
I haven't run into like gauges that I really like, honestly. That's something I almost thought like we should look into making, but we don't do a lot of electronics. I think there's some good options on there, but I kind of prefer data logging. So I think RacePack makes a really slick data logger that you can connect like aftermarket like analog gauges to it, and it'll display everything on either a phone or a tablet. And so you can monitor everything while you're driving, but also you have the data logs to look at later. You can connect that, to an alarm. You can have alarm. I think their software will put an alarm on your phone. You can have a buzz or flash or whatever. So those are
if you have a momentary pressure drop, it's probably going to be in a corner, and your eyes really probably need to be going throrough that corner and not.
Yeah, you got to be able to see it out of the your peripheral. Sometimes being able to hear it is a little better. Yeah. But yeah, I mean, if you, basically any reputable aftermarket brand of gauge that has an alarm is good. I think what's that really popular gauge company? I'm drawing a blank right now.
Our friend Greg has been plugging Speed Hut for a while, so
they make good stuff too. Yeah,
good.
It's not what I was thinking of, but yeah, just ask if they preferably have a buzzer and a light, or you can, if you're handy enough, you can always. And some of them have like an external alarm, like wire sensor or something. You can connect a buzzer or something to it too.
All right, so let's talk about coolers a little bit. What am I looking for to tell the difference between a good cooler and a crappy cooler? What's actually going on inside here to provide our heat exchange action?
Mm-hmm. So yeah, these coolers, a lot of like R&D and development went into these. Actually, we've probably spent like 2 years prototyping and making all kinds of different coolers. We're dealers for Cetrab and Mocal. We sell a lot of their coolers, but we wanted to see if we could make something better. And those coolers, those designs are like 40 years old, a lot of them. So there's room for improvement. So what we did was we built a mini wind tunnel. We have like an oil heater. We have like lab grade equipment, like sensors and stuff to measure oil pressure, flow, temps and everything, all along the setup. And then we put our coolers in there, and it's not ideal because we can't get 100 miles of air through there. It's about 40 max, but it's good enough obviously for testing. Yeah. And we did a ton of bench testing, a lot of different coolers. And this is basically what we arrived at, after a couple of years of development. These coolers, are basically, when you compare it to so this is like an extruded tube row and fin cooler. That's what you call this, but there's also a stacked plate cooler, which are basically formed metal plates that are brazed together.
Okay.
And compared to one of those, you'd have to go about 20% larger to get the same cooling performance as this. Ours is also has better airflow, like a lower pressure drop of air through the cooler. So when it's in front of your radiator, you're
not
still
losing
getting
a ton of flow.
Yeah, you're getting a little better airflow. Our coolers, compared to those stack plate ones too, they're also lighter, like about 20% lighter. They're all aluminum. They have, basically just a few welds, so it's a lot fewer places for leaks. Those brazed ones are just, every single row is brazed together, and here it's just the end of the headers and these, and then these end caps are billet aluminum. Like, we just spared no expense, like, making these. They're just so for the maybe for the money and the compactness of the efficiency, they're pretty good. This cooler is actually these are dual pass coolers. That one is actually a triple pass cooler, which I don't think I've ever come across one before. So we might have been the first ones to do it. And the reason we're able to do that is we have the tanks running along the top and bottom, and so the oil is not actually, if you think about the flip side, if the tanks were on the end and you had rows going across, you'd have much fewer rows, and it'd have a much longer way for the oil to go, and that just increases the pressure drop. But here we have very short distances with a lot more rows. So basically, it's just going through each section, like 3 different sections on this cooler. And that actually made it pretty efficient, very efficient. Like, we tested, doing dual pass and triple pass versus not, and it gains you, 5 to 10% of efficiency. So it's, a nice advantage to that.
Cool. A couple questions coming in. Jonathan wants to know, have any of these products been used by pro race teams? Well, we talked about the Corvette guys earlier.
They're not running our coolers, but
running your thermostats.
We have a lot of customers. We've sold stuff to like the Porsche Le Mans team as well. We definitely have a lot of race teams using it. I see a lot of like Hendrick Motorsports and stuff. Yeah, I see like names, people ordering stuff. I don't know specifically, what they're. I know, like I said, the Corvette racing guys are running our thermostats. Everything else is very custom, like on those cars.
You're just building good stuff, and whoever wants to buy can buy. Okay, we'll get to one last question here. We got to take a quick break in the middle, pay some bills. And you alluded to this earlier. Billy wants to know about pressure drop across the cooler. Obviously, we're adding a lot of distance that it's pumping the oil. Can we expect a pressure drop from adding
you'll
this
see
much?
a pressure drop. And it depends, of course, on the oil viscosity and the temperature of the oil.
Okay.
And that's one of the reasons it's important to run a thermostat, because if you're running an oil cooler and you have no thermostat, and so you're forcing all the oil all the oil through the cooler, and you're like up in Canada or something, and your oil is like freezing temperatures, like your pressure drop is going to be like enormous through that cooler, and it's just not good for the engine. So the thermostat is going to bypass the cooler completely until it gets up to temp. So you won't have that issue.
Okay.
Now, normal pressure drop, so like I'm kind of trying to remember off the top of my head here, but at 100 degrees Celsius, which is kind of normal operating temperature, 212 Fahrenheit, with about 6 gallons per minute of oil flow, which is kind of the max you'll see on an LS engines up at the top. You would see like up to about 5 psi pressure drop on a typical oil cooler, and that's what you get on these. These ones are a little less, maybe 2 or 3, because of what we spoke about earlier.
And
this one's also about 2 or 3. The smaller one might be 5.
So you're probably talking about a motor that's got like at RPM 40 or 50 pounds of oil pressure anyway. So losing.
Oh yeah, I mean at 6 gallons per minute, you're like 60 or 70 RPM, 60 or 70 psi, excuse me, and across the whole oiling system, you're going to see 4, 5, 6 psi pressure drop, which is normal. The factory like cooler setup for the C6, I think, has a pretty, it's like 10 psi or something.
Oh wow.
Yeah, so it's not it's not a bad pressure drop to have.
Awesome. All right, Michael, take a break. I got to pay some bills here. Go get. We have hummus over on the craft services table.
All right.
Hummus tonight.
Oh wow, you weren't kidding. I thought that was a joke.
No,
like
so yeah, when we come back, we'll actually turn a couple wrenches and
right.
and kind of show folks how this stuff goes on and finish it up. In the meantime, we tell you guys about some of the stuff we got going on. First off, next week is Rolex Week. Where are my tickets? My golden tickets, ladies and gentlemen. If you are coming to the Rolex, I have been entrusted with the golden tickets this year. Look at all these. What these are special passes to backstage stuff going on at the Rolex. Maybe somebody coming to the Rolex, maybe I tap you on the shoulder and the next thing you know, you're up on the starter stand. Or maybe you get one of these golden tickets and we go to the driver's meeting for the Rolex 24. Or maybe you get a hot lap in the right seat, one of the VIP cars before the race. All kinds of cool stuff. So I cannot legally, take any sort of compensation or bribes for these, but between you and me, fried chicken, calf massages, a pair of Merrills is size 11. It's going to go a long way towards getting you one of these. So if you are coming to the Rolex next week, maybe be lucky enough. If you don't win a golden ticket, come hang out at the GRM Fun Activities Center. If you want updates on what's going on all weekend, you can text Rolex, ROLEX, to 31996. Yes, 31996, and we'll send you text updates throughout the weekend when our tours are happening, when functions are happening at the tent. All kinds of really cool stuff going on there. We've got, I'll get to that in a minute. That's interesting too. I haven't even done that yet myself. We have, Katie, bring up for me the sponsor list for the Rolex. I want to name drop all of those folks, or somebody bring up the sponsor list for the Rolex, because I want to make sure those folks get their due, because we got some awesome folks coming out to that. In the meantime, while they're doing that, don't look at my search history. That would be bad for both of us. I want to tell you guys about the folks that make this show possible. Talking about our friends at CRC. I use some of their new Weld Aid product over the last couple of days. This is maybe my new favorite CRC thing. They have now acquired Weld Aid. This is the stuff you use to prep your metal before you weld. It is fantastic. Everybody, of course, knows about Brake Clean. This Brake Clean Pro Series, I've been seeing more and more of this stuff out in the wild, and it is Brake Clean, just in a bigger can, which the only thing better than Brake Clean is more Brake Clean. We are very, very honored to have them as part of this show. We're very honored to have them as part of our events like the $2,000 Challenge. So check them out online, crcindustries.com, even better. Check them out at a retailer near you, Lowe's, Home Depot, Harbor Freight, O'Reilly, Napa, Advanced Auto Parts, any of those places sell their fancy red and silver and blue cans. Please, please, please do me the favor of giving them some business. Also, I want you to check out our friends at Autobooks Aerobooks. We got a video from our Autobooks friends this week. I think it is Matt Stone telling us about his new book. So take it away, Matt.
Hi, I'm Matt Stone, and this is my new baby, my new book called Hot Rod Empire. If you love Margie and the epic Robert E. Peterson, all the magazines they created, the whole birth of hot rodding in California, their museums and car collection, it's all in here. I'm very proud to have known these epic people. You can buy my new book, Hot Rod Empire, from autobooks-aerobooks.com in Burbank, California. Order right now and they'll have it to you as quick as they can. Thanks for watching.
We're back. Before we get back to Michael Ihns, I want to let you guys know about some of our partners at the Rolex. Of course, Coney is going to be there. They will be doing tech talks throughout the weekend. They are going to have actually representatives there on site talking shock tech with you. Haggerty Insurance. I have bought Haggerty Insurance for this very car the last couple events. $225 for $30,000 of on-track time trial insurance. That's way. It is a confidence-inspiring move. I did not realize how much better I would feel on track knowing that I could not worry about balling the car up, other than having to dig it out. Also, our friends from Covercraft are going to be there. BBS Wheels will have a booth set up there. ZMAX, Lubricants, Auto Lift Productions. We're going to have a car up on a lift. It's really cool. It's actually drill powered, like hand drill powered. It can lift an entire car. It's a mechanical marvel. We'll have a car up on that for you guys to check out. Intercom Scales, of course, our sponsor of our What's It Weigh presented by Intercom. Next week we'll be doing another edition of that. They will be out at the Rolex. Spec Clutches and Flywheels. Going to be out there talking to you guys. Krispy Kreme Donuts. He'll be giving away donuts every single morning. And our friend Andrew from Apex Pro will be out there talking to everybody. And our new friends from White Pony Absorbent Products. They were the ones that gave me that little bag of white powder that apparently anything wet on the ground, you pour that stuff on it, it just makes it disappear. And
sure
it's
sending it for the goodie bags.
Yes, and I think your Daytona goodie bag is going to have some of that stuff in there as well. And they're going to be. I cannot wait to see a demo on this. I haven't wanted to use the stuff I have. I want to wait to see an actual demo from an expert. Speaking of demos from experts, our friends from Nordlock are going to be there. I'm so excited about that. The locking washers, which are just the most amazingly simple little pieces of engineering you have ever seen. And it will blow you away at how good they are. I'm really, really excited that they are working with us. I think that's a great venue for them. And just to go by and see how those things work is going to be really, really cool. So come to Daytona next week. If you don't have one of our GRM experience tickets, that's fine. You can come in. You can hang out with us. You can
Buy a front stretch seat.
yeah, you can buy a front stretch seating package. Those are still available. You get breakfast on Sunday morning. Get to hang out in the suite there on Sunday morning. And if you do have a GRM experience ticket, maybe we get you hooked up with a golden ticket, and maybe I get a bucket of chicken for my troubles. I'm not saying the two things are related, just saying the two things might happen, and who knows. All right, let's get back to it. Yeah, we got a lot of people asking for little bags of white powder. We need to clarify that next week. Michael, get on back in here. Let's do a little bit of work here. I want to, Chris, come on over and let's show everybody where the thermostatic adapter goes. This thing that we're going to kind of put up in place here, this is pretty clever. This is essentially the adapter that's going to go out to out of this one, obviously, to
It's your cooler.
it's the cooler. What's happening inside this right here?
So the way it works is it has a thermal actuator in there. It's basically a valve that's sensitive to temperature, and it's a little bit counterintuitive. Some people, I'll try to explain it. So there's a bypass passage basically connecting these two ports, and normally this is connected when the engine is cold. And so what happens is like 95% of the oil is just going to go through that passage and go back into the engine because of the resistance to flow through the cooler, especially when it's colder. It's kind of like an electrical circuit, and it's kind of like two things in parallel, and it's just going to take the path of least resistance.
Okay.
So once it gets hot, this valve closes, shuts that passage, and now it forces 100% of the oil flow through the cooler, just as if thermostat wasn't there. So pretty simple.
Okay, so Chris, get a shot up here of where this actually goes, and I just had actually a better idea than putting this on. So we're going to remove this port here that is essentially for the oil temperature or the oil.
That is oil temperature.
Temp gauge.
Yep.
Okay. So and there's an adapter that comes with this for the.
Yeah, you should have received a
I have the
sensor.
box over there. So,
Correct.
So two bolts and a gasket. But actually, instead of putting this on, let's put this together on the bench actually, because that way everybody can see the entirety of the circuit, because I think not enough attention sometimes is paid to what happens between that and the cooler. So let me go over to the bandsaw and separate this into two pieces. Katie, a little bandsaw music, please. That's not the cow video. We'll get to that in a little bit. So walking over to the bandsaw.
If you want to start.
All right, earmuffs, everybody.
You don't want to hear me sing.
So let's mock this up and look at what an entire circuit looks like, basically. So we're gonna. So when I'm routing hoses for an oil cooler, what do I want to avoid? Obviously, I want to avoid heat sources, but
Yeah, there's a few things you want to avoid. You want to avoid having the hose against anything abrasive, where from just small vibrations and movement in the hose, it could wear a hole in the hose and cause a leak.
okay.
So you kind of want to secure the hose so it's not doing that, and add protection to the hose as well. We also have heat sleeve to protect it from like headers and other heat sources. And then the other thing you want to avoid too is routing your hose. You don't want your hose routed like under your subframe at the lowest point of the car, because if you hit something at the track, you can rupture your lines. So you kind of want to be smart about it, keep it out of the way of harm, essentially.
So how about the actual routing? I want to avoid low spots for the purposes of protecting the hose, but
Right.
if my hoses are changing level quite a bit, is that affecting my pressure drop at all?
Not really. I mean, the more bends you have in your setup, the higher your pressure drop. So you kind of want to avoid having, like when you have a 90-degree fitting, this adds a pressure drop versus it being straight. And how tight this radius is will also affect the pressure drop. But, with a setup with this thermostat, it's pretty simple, because you just have 2 lines going to your cooler. You're really just going to have 4 fittings. So, yeah, I mean, it's pretty straightforward, really.
So if given the choice between a shorter hose that maybe goes close to an exhaust manifold and a longer hose that doesn't, am I by adding hose, I mean I'm adding weight, I'm adding more area it has to pressure. How do I make that decision? I mean, do you always opt for keeping this?
It depends too on the size of the lines you're running. If you're going to have long lines, for example, if your engine is in the rear of the car and your cooler is in the front, you definitely want to run at least -12 oil lines, maybe even bigger. For most setups, you're looking at usually around 8 feet of line or so, and we recommend using -10 lines for that.
Okay.
The pressure drop difference between like 10 to 12 when you have 8 feet of line is like less than a PSI, for example. So it's like it's pretty negligible. But if it's from 10 to 8 at the flow rates that these engines see, 6-7 gallons a minute, it'll be more like 3, 4, 5 PSI. So then it's definitely worth going with 10. And if you have really long lines going to the back of the engine, like I said, you want to run bigger lines to minimize that pressure drop. So yeah, just it kind of depends on the length of the line, and you can just adjust for that by running larger lines as well.
Your AN fittings, by the way, I was really impressed with. They go together by hand. You don't need a lot of.
A lot of it is this hose. We love this nylon hose. It's super easy to assemble. It still has stainless reinforcement in here, so it can't collapse or anything. But having this nylon makes it like 30% lighter than stainless braided, and it's just like it just goes on like butter, like you're doing it here by hand.
And I'm not going to put you guys through the torture of using an actual wrench on this, which I totally do because it goes under my car, and if there's a scratch on it, what's going to happen? Fine, whatever. But I'm not going to do that on TV because I know everybody will panic. Like, oh, you got to use AN wrenches on there. You know what? It's not that I don't respect it. It's that. I can only Marie Kondo myself into so much organization and cleanliness before it's a race car, for God's sake. When you're putting this hose and stuff together, this stuff goes together super easy, which I like a lot. But any good advice to somebody? Obviously, you want to blow the lines out.
Yeah, make sure they're clean. Use a little bit of motor oil when you're inserting the fitting. It goes in a little easier, be easier to screw together. Use AN wrenches if you don't want to scratch it up.
Yeah.
They're aluminum, so they're kind of easy to scratch. But that's the price you pay for lightweight.
Yeah.
So I mean they're not that difficult to assemble.
So I'm just kind of putting these together by hand, and we'll send them to one of these coolers and just kind of see what an entire circuit looks like. So when we come out of our adapter here, and let's use that cooler because it looks like it's already plumbed for.
Yeah, there we go. It's already got the fittings. Yeah.
So I'm going to go out of my Where's my outie here? Here's my out. So I want to. Does it matter which of these I go into? Do I always want to go in on the top and come out on the bottom?
Yeah, I mean, typically if you have a cooler with the lines on the side like this, you're going to want to come in from the bottom and out the top. And the reason for that is to minimize how much trapped air you'd have in the cooler.
Okay.
If you're going this way, you'll have some air bubbles in here that'll just never make their way out. So one of the downsides to the triple pass cooler is it can be a little harder to get the bubbles out. So what we do is we'll connect the lower line, then just use like a small hose or funnel or something and fill this with oil first, and then you just connect the upper line real quick. And the other reason to do that too is you don't want to start your engine and have it be dry of oil. So at least your cooler's filled with oil. We recommend then like pulling the fuel pump fuse and cranking it over a few times to pump a little bit of oil through the lines and everything, so that when you start your engine, it's not totally dry.
So this is what my complete circuit is going to look like. Do I care when I'm building this if my output line is longer than my return line? Do they need to be
That
the
doesn't
same-
matter.
same
No,
length?
that doesn't matter. Makes no difference.
And of course, they should stick out the front of your car and twirl around.
Yeah,
so
if you want to be cool, yeah.
at the.
Make sure everybody knows you have an
cruise
oil
ends.
cooler.
So how if I'm talking about a transmission cooler, say, and I'm running a bunch of line from the back of the car all the way to the front, do I want to put my coolers at the front of the car? Can you, if you have airflow in the back somewhere, do you do what you can to keep those lines short to minimize?
Yeah, I mean, you obviously
problems?
want to put it somewhere where you have airflow. The front of the car is where you're going to get the most airflow. A lot of times if you're doing a transmission cooler or something like that, and especially if you don't have room up front, you'll put a fan on your cooler. The transmissions don't need as much cooling, so you'll be able to run a much smaller cooler. You can run a fan, which doesn't get the same air speeds you get just from driving on the track, but it'll be sufficient. It's also a much lower flow rate. Usually, like 2 to 3 gallons a minute is what a typical automatic transmission flows. And if it's a manual transmission, you'll have to add an electric pump to circulate the oil.
Okay. And how about airflow to an oil cooler? We were actually looking, because you guys are going to be building a kit for this car shortly.
Right.
We were looking for real estate up front.
Yep.
And we were looking, we have these nice big gaping holes here with some area behind them, but not quite enough for that. But maybe you could divide it in half. But there's good room under inside the.
Yeah, there's actually a pretty decent amount of space.
So, do I worry about the fact that I've got a radiator and then an AC condenser, and then I'm going to stack another cooler in front of that? I mean, or is the flow through good enough on all these things where I'm not really slowing anything down too much?
Yeah, I mean, that's the you don't want to block too much of the flow, and that's one of the nice things about these coolers is that they allow a lot more airflow through the cooler. But that's typically what you have. A lot of factory setups, you have multiple heat exchangers stacked, and there's not a whole lot you can do. If you do have, like some cars have dedicated oil cooler locations, like the FD RX-7, the car I have, it has locations for dual oil coolers on each side, which is awesome. And that's getting dedicated air, through one of these ducts.
So this is actually the cooler we're looking at using in here. I think hold that up there for us. Let's get a shot of kind of where you think it's going to end up. As you guys start to develop this, like what are you looking at there? You're looking for mounting points, obviously, and airflow, but is there any other considerations?
So I mean, this will fit pretty nicely, like right here in front of the AC condenser. And what we'll want to do is we'll probably design a bracket that bolts it to this bar right here, this frame rail. And then the tricky thing on this is going to be figuring out how to secure the top so that the top is stable. Because when you have a lot of...
Sorry, Chris. This is just kind of the plastic air box.
Yeah, there isn't really a good spot up there. We'll figure something out, because if you have a lot of airflow hitting this cooler, if you're 150 miles an hour, it's going to push the top of the cooler against your condenser. So you want to keep it really steady. But at the same time, you don't want to hard mount the cooler, because
cracks.
You have vibration issues, and the cooler expands and contracts with heat as it warms up and cools down. So if you look at any radiator, it has those like rubber grommets in there to accommodate for that.
Okay.
So our brackets have little rubber grommets in it that have a little bit of give for that purpose as well.
So for something like that, do you want the entire face exposed to airflow? Like if we were going to try and put it behind one of these where you had just the middle exposed to
Right.
airflow and the top and bottom blocked off, are you just losing efficiency there?
I mean, it's a little better if you have the air hitting it directly, but you have just a mass of air that's coming in through here and it's going through that everywhere it can go through, around the radiator and everything. So it's not as important as you would think, to duct it around. I mean, as long like you have that nice under tray here, it's going to keep air, ducting like going straight through the radiator. Like all that air has to go somewhere and it's going to go through this. So.
And as we found, like with our Mustang project, the biggest part of that we had trouble with cooling was not getting air into it, is getting the air back out of it.
That's why a lot of people duct their hoods and get the air out of the hood, the top of the hood. So, but what I want to know too is, we could also use that cooler.
Right.
So maybe people watching could give us some input on which cooler they prefer that we use, because that one will fit as well. It might actually be a better choice, and that is the best performing cooler we have. It's a little larger. This thing will fit in here too. So. We can mount that right in there. We'd offset it to the left a little bit so we'd have space for the fittings, but yeah, I mean, this one's more expensive. This cooler is $599. The other one I think is that one is, I think it's $349. So it's a pretty big price difference.
So what are you looking at for a complete kit then with the adapter and the hose? You're still looking under $1,000.
Probably about $1,000. Our C6 kit is $1,000. Camaro kit's probably going to be $1,000. So.
And how much actual oil capacity are we gaining with something like this?
I believe this cooler is about well, it actually says right here. This is 1 quart of oil.
Okay.
This will hold 1 quart. This one is because of these huge end tanks. This will hold almost 2 quarts, 1.94 quarts of oil. So you're adding 2 quarts of oil capacity to your car, which is great for endurance cars because you're not, your oil is going to last longer, basically. You're just adding the oil capacity is going to stay clean longer. So that is another nice benefit of this design, with this setup. So
awesome.
Big end tanks.
So I'm excited. So we're going to bring the car over to you guys in Kissimmee. You're going to work on the kit. I'm going to come pay you a visit a couple of times. I'd love to see your process, kind of how you go through it. What's your process kind of look like in general for designing that? I'm sure there's going to. Do you just sort of eyeball it? Do you laser scan it? What happens?
We try to get CAD models. We have CAD models for a lot of GM, factory cars and the bumper and the whole front end and all that stuff. So it's always easier when you have that because you can just mock it up in CAD super easily. But so we have that, and we'll kind of design some prototype brackets. We have a laser cutter, and we usually use acrylic actually.
Oh, wow.
We'll cut the acrylic, and we can heat it up and bend it, so we can make some prototype brackets and test fit everything. The rest of the stuff is pretty easily just figuring out the line routing and measuring the lines and everything. And once we have a design we're happy with, we'll usually make some prototype brackets, machine them out and everything to test it out and make sure it fits. And if that's all good, then we go to production with the mass producing some brackets. Yeah.
And what's the time window on that? Like from the time you guys bring a car in the shop to the time they're on the website?
It varies depending on how many little issues we run into that we have to figure out. We spent more time than I care to admit trying to figure out a little mounting clamp for the hoses at on the front of the Camaro.
Wow.
Like just looking at all kinds of different clamps and things. I'm like, I don't want to make a custom clamp. This is going to increase the price of this kit by like $100. We need to find something off the shelf. So it just depends what type of issues you run into. But usually we'll take a car for a week, maybe two, depending on how it goes, to figure everything out, make prototype brackets and everything. A lot of times we can fab up our own brackets right there and have the whole kit, set up and everything, and we'll just have them come back in for the production brackets and put them in later if they want them. And then it's usually 4 to 6 weeks to get everything made and
Powder
put
coated
up on the shelf. It's ready to go. So a couple months probably.
It's not bad. And thanks for
If we're
doing
lucky.
Central Florida, man. We appreciate it.
I really appreciate you having me.
Helping
Thank
pay
you.
our taxes. All right, Michael Ihns, Improved Racing. We're going to be seeing them at the shop. You'll be seeing more of the kit once it's installed. And I have learned a lot tonight. Follow up on a couple of questions here before we get out of here. Greg wants to know if you duct it right, you can run a smaller opening. I think the point we're making with getting airflow is trying to get airflow to as much of it as you can. But
yeah, aerodynamics is a pretty complicated subject. There's some of it is counterintuitive in that sometimes you can have ducting that you would think that if you had a duct like on your cooler doing this, it would funnel more air through the cooler. And depending on the design, sometimes a duct like this will actually suck a more mass of air like through the cooler, and it's because of aerodynamic magic stuff that none of us really understand. So it just depends.
And actually, it's a good question to end on. Thomas wants to know about what does this do to my oil change procedure now? Is there anything I'm going to have to do differently when I'm changing the oil?
Yeah, that's a common question. Not really. Like some oil is obviously going to still be in the cooler. It's usually not a big deal because in this cooler it's 2 quarts, but it'll just mix in with your new oil, and it just mixes in. It's not a big deal.
So I don't necessarily need to bleed anything.
If you were super anal, you could remove the bottom line and drain the cooler. But then you have to fill it. It's just it's not worth it. We initially did design our coolers to have a drain port, like thinking that you could do that, but we eventually decided it wasn't worth the extra cost. For it's just not necessary really. And so you don't have to do anything really. It's just
just change it.
The oil stays in the cooler and it'll mix in with the new oil. It's not a big deal.
And I think to some extent, if you're in a world where you're needing a nicely designed oil cooler, your oil change schedules are probably frequent enough where
anybody installing this cooler, I hope, is changing the oil every 2,000 miles.
They aren't going 10,000 miles.
Right. Yeah.
All right, I think we are caught up on questions. Yep, awesome. Hey, thank you very much for coming by. We will see you again real soon. And I will let you folks know on the way out a couple of quick things. Yes, Katie was wondering about this. So I would like to take a minute here. Every once in a while, we take a minute. First off, we appreciate each and every one of you out there that are watching this show. So every once in a while, I like to go through the comments on some of the videos, and I'd like to take a few minutes to read some of the comments from folks out there watching the live show. This one's from Tracker Buckman, and Tracker says, "For the love of God, how long is this guy going to talk about nothing?" So that's a great comment, Tracker. So I was thinking that your input on the show is valuable. So I wanted to see what you were producing. Maybe we could get some ideas from some of your videos. So here's a video from Tracker's page. Katie, go ahead and run that.
What are you gonna do? Huh? What are you gonna do? Yeah? You f***ing nut job? Huh? What? What? What do you got? What do you got? Huh? What do you got? Huh? What are you gonna do? What are you gonna do? What are you gonna do? Huh? That's a crazy cow.
All right, you're back.
All right, so now I have to fight a cow. So that's what it's come to. Next week on the show, we will have a cow in here for me to fight, apparently, because that's what everybody wants. The donkey is gone, so now I've got to fight a cow. Thanks, Tracker. Thanks for getting me into that. We appreciate your comments. We appreciate everybody who's watching. For real, though, next week we're going to have the folks from Stable Energies here. Last week we talked about personal safety. Next week we are talking about vehicular safety. Our VW Fox race car is going to be in here next week. We're going to be talking all about safety with the folks from Stable Energies, belts, roll bars. We're going to be talking about window nets and roll bar padding and rear view mirrors, all that stuff next week on the show. Katie is tapping her nails on something. Oh yeah, check this out. So remember I gave you that number you could text Rolex to earlier. Number is 31996. You text Rolex to that number. You get updates on our stuff going on at the Rolex 24 next week in real time. If you text the word GRM Live to 31996, I come to your house and fight your cow. No, you will get weekly updates on what is going on with the show, who's coming up, who the guest is, what the subject is, what I might be doing. I could be out cutting my hair in the middle of our yard on a Tuesday night. I will text you from the yard, and you will get that. So yeah, GRM Live to 31996, and you'll get updates on the show every week. We promise not to feel like it's not going to be me like crying that I'm sad and lonely. It's going to be actual work stuff. So don't panic. Let's see what else. Yeah, it's up on the board there. All right, that's it. Isn't that enough? Haven't I given you enough? Thanks very much to Michael Ihns for being here from Kissimmee tonight. Thanks very much to our friends at CRC Industries for providing the great products we use in the garage and providing this show a home, and for being great sponsors of events like our $2,000 challenge. And thanks to our friends at Autobooks Aerobooks out in Burbank for, I love watching their videos. And yeah, it's great what Matt's talking about or what Jerry's talking about, but I love looking in the background and seeing all the amazing stuff they have there. It is like walking into a museum where you can just buy everything. It's so cool. If you're out in Burbank, it's worth stopping by. They have great live events every week, book signings, book rollouts. The celebrities are hanging out there. And if you can't make it there in person, autobooks-aerobooks.com on the web. Thanks very much to Chris behind the camera, to Katie, who got one of those bar things through her ear, so she's got to sleep on her right side for like the next 4 months. And she's been sort of very gingerly tilting her head back there and trying to get sympathy from me all night. Our director, you totally have. And David, running social media. I'm JG Pasterjack. This is GRM Live, presented by CRC Industries. Next Wednesday, 9 p.m. Eastern, everybody. We'll see you then. Good night.